in Edinburgh, Scotland, some 200 years ago. In the late 1790s, the Industrial Revolution and the political revolutions in France and America were being felt around the world. This spirit of change inspired radical new ideas in science. In the dogma of the day, Earth was created by heavenly forces, and its surface shaped by the great flood of the book of Genesis. By counting lifetimes in the Bible, leading churchmen had pronounced that Earth was created precisely in the year 4004 BC, on October 26th, at 9 in the morning. The Earth was a mere 6,000 years old. But 18th century Edinburgh was a source of intellectual ferment. Among the geniuses of the now famous Scottish Enlightenment was James Hutton, the father of geology. Hutton spent a lifetime puzzling over the Earth. He would challenge, then change the dogma of his day. Sketches for Hutton's book document his keen observation of nature. Might the rock layers be different worlds, each with its own origin? Hutton scoured the crags of Scotland in search of clues that would tell how these worlds were formed. 18th century wisdom declared the Earth's landscape fixed and unchanging. But the extinct volcanoes surrounding Edinburgh aroused Hutton's skepticism. They suggested to Hutton a surface that was dynamic and constantly changing, driven by what he called the Earth's great heat engine. Gordon Craig is the James Hutton Professor of Geology at the University of Edinburgh. Here, on Edinburgh's ancient volcano, Arthur's Seat, and along the Salisbury Crags, he explores the rocks that told Hutton of a living Earth.
Wasn't it marvellous that Hutton should have this as his backyard, an old volcano? He used to walk here with his dog called Missy, and the detailed evidence that encouraged him in his theory of the Earth was right here. Because here you can see evidence of rocks overlying each other. The prevailing view towards the end of the 18th century was that all rocks were laid down in water. Not so far as Hutton was concerned. Hutton believed that these rocks, actually this particular rock, was intruded into pre-existing rocks. It was a molten liquid that had come up from below as part of a dynamic Earth.
But another radical idea, geologic time, was needed before this restless Earth could be understood. Hutton wondered, how long must it take to wear down a whole mountain? Built in 200 AD by the Roman army, Hadrian's Wall stretches from sea to sea across northern England. Erosion relentlessly destroys the landscape, but Hadrian's Wall hadn't changed much in 16 centuries. Hutton recognized that mountains must take millions of years to wear down, not centuries. That Earth must be far older than 6,000 years. Radioactive dating now suggests an age of 4.6 billion years, 1 million times older than thought in Hutton's day. When a mountain wears down and washes to the sea, the ground-up mountain forms flat layers of sand and mud. Here at Sicker Point, Hutton found one set of horizontal rock layers, but beneath these were others, tilted on their sides. What force could possibly bend solid rock in this way? Gordon Craig explains.
I guess this must have been one of the most exciting localities Hutton had ever seen. He was in his 60s, it was probably his last geological excursion, and he came across really what was the essence of his whole theory of the Earth. Because here he realized that there were vertical rocks here which had once been horizontal sands and muds. They had been folded by immeasurably strong forces, they've been uplifted, they've been eroded, and on top these much younger sediments have been laid down. This cyclicity of operation, of erosion and deposition, of old lands wearing away and new lands being formed, was the essence of his theory of the Earth, a dynamic Earth as we know it today.
By asking how these vertical rock layers could have formed, Hutton made one of the great leaps in mankind's intellectual history. The rocks told a story of an Earth that was both ancient and dynamic. In his words, with no vestige of a beginning, no prospect of an end. The theologian's 6,000 years became but a single tick of the geologist's clock. Our view of Earth would never be the same. In the century that followed, scientists would explore further than ever before. German scientist Alfred Wegener was at the vanguard. Rare footage of his final expedition to the icy heart of Greenland in 1930 still speaks of a time when much was to be learned in the far reaches of the Earth. Science here was a struggle against the deadly powers of nature. These rigorous expeditions would enlarge Wegener's curiosity about the Earth. Wegener conducted many meteorological experiments, but he was curious about more than weather. He was puzzled by glacial deposits in the tropics, by identical fossils on continents thousands of miles apart, by mountain ranges with the exact same geology, but separated by vast oceans. His curiosity drove him to seek an imaginative solution to these scientific puzzles. Like Greenland's sea ice, perhaps continents could also split and move apart. Wegener's bold leap was to reconstruct a world where the continents fit together. His sketches connected broken mountain chains and solved other unanswered problems. This single giant continent is called Pangaea, all lands. Though based on careful scientific reasoning, Wegener's ideas were dismissed as fantasy by scientists of his day. No force could possibly plow whole continents through the bedrock of the ocean bottom. Wegener died in Greenland, lost in the far reaches of a frozen wilderness. But his vision of moving continents would haunt the scientific world until new discoveries at the bottom of the sea revived his challenging ideas.